Welcome students into the 12th science chemistry class. Today we are learning the chapter number 1, that is first chapter, solid state. In 11th standard we very well familiar about the state of matter. There are the three distinct states of matter: solid, liquid and gas. The liquid and gaseous states we learn already into the 11th standard in details. Now in this 12th standard we have to learn in details the third state of the matter, that is the solid state. We know that due to the intermolecular or interparticle forces of attraction between these particles of solid, liquid and gases, they can be distinguished from each other. We know that in solid state the intermolecular or interparticle forces of attractions are very much strong, and that's why solid have the definite shape and definite volume. Now the solid state of matter is the characterized by strong interparticle or intermolecular forces of attraction, and therefore as a result solid have definite shape and definite volume. But in case of liquid, the intermolecular forces of attraction are intermediate between the solid and gaseous state, so they only have a definite volume but not a definite shape. And in case of gases, you know that the particles of gases or molecules of gases are independent. There is negligible attractive forces between them, and therefore gases do not have a definite shape or definite volume. The smallest constituent particles of solids are generally atoms, ions or molecules. And in this chapter, which will be called as particles, in this chapter we have to call them as particles. They may be atom, ion or molecules of the solid, but we call them as the particle in this chapter. Now there are mainly two types of solids: crystalline solids and amorphous solids. Now crystalline solids are the solids such as, that is the salts, copper sulfate, sodium chloride, or they may be the metal like gold, silver, copper, or they may be the material like plastic, graphite, diamond, etc., or glass. But the amorphous solids, now glass is not the crystalline solid but it is the amorphous solid, it is super cooled liquid. Now what is the amorphous solid? How we can say that they are the amorphous solid? Now in amorphous solid the arrangement of the particles is not in a regular pattern or in a definite arrangement in the amorphous solids. So glass is the best example of the amorphous solids. Now let us learn about the crystalline solids. Which are the characteristic properties of the crystalline solids? Now the first property is that there is the regularity and periodicity. That is same pattern of the arrangement of the particles, that is molecule, atoms or ions, repeated again and again. So there is the regularity and periodicity in the arrangement of the constituent particles in crystalline solids. In crystalline solids, the arrangement of particles are in a regular pattern. There is regularity and periodicity of the particles in case of crystalline solid. Now in this figure, these are the red particles which are in a definite arrangement, and again the blue particles are also in a definite arrangement. Such type of regularity and periodicity of the particles are present in the crystalline solid. But in amorphous solid, such regularity of the arrangement of the particles is not there. So the first main characteristic of the crystalline solids are there is a regularity and periodicity in the arrangement of the crystalline particles in the crystalline solid. The constituents particles in the crystalline solids. And the ordered range of particle extend over a long range. There is over a long range that ordered arrangement of the particles will be there in the crystalline solids. Again, the second property is that, or second characteristic of the crystalline solid is that crystalline solids have sharp melting points. That is, they melt at a definite temperature. The melting point of the crystalline solids are definite or fixed. They melt at a definite temperature. Their melting points are sharp. But in case of amorphous solid, they melt in a range of temperature. There is not sharp melting points of the amorphous solids. Again, the third property is that all crystalline substances except those having cubic structure. Now, besides cubic solids, all the other crystalline solid show anisotropy. That means all the crystalline substances except those having cubic structure are anisotropy. What is anisotropy? Now, that is the property of the crystalline solid in which that is refractive the such properties such as refractive index, then there is the different in the conductivity, thermal and electrical conductivity will be changed if the direction of the arrangement of particle is changed. That means, in other words, anisotropy means their properties like refractive index, thermal and electrical conductivity, etc. are different in different directions. Now see here, this is the one direction, direction B. This is the another direction, direction D. And this is the third direction, direction A. Now in all these three directions, the arrangement of particles are having the different that is pattern. And therefore the refractive index, thermal and electrical conductivity will be changed in the all these three different directions. That is anisotropy. So crystalline solids show the anisotropy. Now which are the examples of crystalline solid? Ice, salts such as sodium chloride, copper sulfate, metals such as gold, copper, sodium, and the materials such as diamond, graphite, ceramic, etc. are the examples of the crystalline solid. Now let us learn about the amorphous solids. Now pay attention students on a blackboard. Now learn about the amorphous solids. There is always a difference or a distinction asked into the board examination between the crystalline solids and amorphous solids. We learned the crystalline solids. Now let us learn the amorphous solids. Now these amorphous solids are basically, they are the super cooled liquids. They are same as that of the liquid, but they in a stable motion. That means the particles of liquid are always in a constant motion. We know that. And if the stop action photograph of liquid is taken, if we take the stop action photograph of liquid, then it describes the amorphous state. So amorphous solid in fact are supercooled liquids. In fact, amorphous solids are supercooled liquids. Glass is the best example of the amorphous solid. There is the glass to the windows of the old houses, which are always thickened at the bottom and they are thinner at the upper or top region. Why that is so? because in so many years that supercooled solid, that is the glass, always flow, but the viscosity is very much. So after some years, many years, the glass, the window glass always thicken at the bottom. Now that is the best example of the amorphous solid. Now which are the characteristic properties of these amorphous solids? We learned that in the crystalline solid there is the definite arrangement of the particles in a long range. That means there is the regularity and periodicity in the arrangement of the particles of the crystalline solids over a long range. But in amorphous solid, such condition is not there. In amorphous solid, though there is the definite pattern of the arrangement of the particles, but they are not in a very long range. That means the constituent particles in amorphous solids are randomly arranged. They are randomly arranged, not in a definite pattern. The particles do not have long range of order structure. The particles in the amorphous solids do not have a long range of order structure, but they do have a very short range of order. Now, this is not in the crystalline solid, but there is the long range of order and pattern into the crystalline solid. So, in amorphous solid, the constituent particles E are randomly arranged and the particles do not have a long range of structure, but they do have a short range of structure or short range order. Now, the second, that is the characteristics of the amorphous solid, is that amorphous solid do not have sharp melting points. We know that the crystalline solids have the sharp melting points. They melt at a definite temperature. But in case of amorphous solid, there is not a sharp range or sharp melting point in case of the amorphous solid. That means they do not melt at a definite temperature, but they melt in a range of temperature, over a range of temperature. So, amorphous solid do not have sharp melting point. They melt gradually over a temperature interval. That means, for example, if there is a solid that is amorphous solid and its melting point is in the range of suppose 400 to 410 Kelvin temperature. That means in the range of these, it may be melt at 405, 406, 401, 402 Kelvin. In this way, there is not a sharp melting point in case of the amorphous solid. But in case of crystalline solid, they melt at a sharp melting point. If there is the melting point of the solid, that is crystalline solid, is 405 Kelvin, then it always, if it is in the pure form, it always melt at 405 Kelvin. That is the difference between the amorphous and crystalline solid. So, amorphous solid do not have a sharp melting point. They melt gradually over a temperature interval. On heating, they continuously and gradually soften and start to flow. If we give heat to the amorphous solid, then they continuously and gradually become softer and softer, and they flow also. And in this way, they do not have a sharp melting point. You may in the childhood, you may heat the bangles and you make that is the garlands of the bangle. On heating them, the bangles glass becomes softened and you can make a garland of that bangles. Now in this way, the amorphous solids become softened and start to flow. They are isotropic. Crystalline solids are anisotropic. That means the properties such as refractive index and the thermal and electrical conductivity may change with the direction. But in case of amorphous solid, they are not anisotropic, but they are the isotropic. That is, their properties such as refractive index, conductivity, etc. are independent of the direction of measurement. in all direction their refractive index and conductivity are the same. So they are the isotropic. Amorphous solids are isotropic. For example, glass, plastic, rubber, tar, these are the examples of the amorphous solids. Now let us learn some property about the solids again, that is the isomorphism and polymorphism. Now what is this isomorphism and polymorphism? Now these are the similarity or dissimilarity in the crystal structure of different solids. Now this is related with the similarities and dissimilarities of the crystal structure in the different solids. Now therefore they are described as the isomorphism and polymorphism respectively. Similarity means isomorphism and dissimilarity means polymorphism. Now let us learn about the isomorphism. Which are the isomorphs? Now the two or more substances, if they have same crystal structure, two or more substances having the same crystal structure are said to be isomorphs, or the phenomena is called as the isomorphism if the two or more substances have the same crystal structure. In these substances, the chemical composition has the same atomic ratio. For example, this NaF and MgO, sodium chloride and magnesium oxide, these are the isomorphs because they have the same chemical constituents of their constituent particles, such as 1:1 ratio are there in these both NaF and MgO. Again in this sodium nitrate and calcium carbonate, NaNO3 and CaCO3, there is also the same atomic ratio of the constituent atoms, such as 1:1:3. That means sodium 1, nitrogen 1 and 3 oxygen is there. Here also calcium 1 atom, carbon 1 atom and 3 oxygen. So these are the isomorphs. Now let us learn about the polymorphism, or what are the polymorphs. Now let us learn, students, about the polymorphism. Now as the name suggests, there are the different forms. Poly means more, forms or more structures. Now if a single substance that can exist in two or more forms, that is the crystalline structure, is said to be polymorphs. Now the substance which is actually a single substance but it exists in two or more different crystalline structures, and that structures are called as the polymorphs. Now, and the phenomena of occurring a single substance into the different crystalline forms is called as the polymorphism. For example, yes, these polymorphs of the substance are formed under different conditions. That means we know now this polymorphism is occur in the elements, then the polymorphism is called as the allotropy. Now we know the allotropes of that of the carbon, such as diamond, graphite, fullerene. Now all these three different forms of the carbon are formed under the different conditions. So they are the polymorphs of the carbon. But if they are in the elemental condition, so they are called as the allotropes also. And if the different structures are of the compounds, then they are called as the polymorphs. Now for example, calcite. Calcite is the structure of the calcium carbonate, that is the CaCO3. So calcite and aragonite, these are the two different forms of the calcium carbonate. So they are the polymorphs, calcite and aragonite. Again, the three different polymeric or allotropic isotopic forms of carbon are the diamond, graphite and fullerene. Now you know the silica, silicon oxide, that is the sand. Silica means sand, that is the silicon oxide, silica, that is the sand. Now the three crystalline structures of this silica are the alpha quartz, beta quartz and crystallobite. All these three are the several forms of the silica, that is the sand, which are the polymorphs of each other. Now this is when polymorphism, when occurring in elements, it is called as the allotropy. Polymorphism when occurring in elements, it is called as the allotropy, and the polymorphs of the elements are called as the allotropes of each other. Now this is about the polymorphism, and that is we learn about the, that is also called with that the polymorphism and isomorphism. Now iso means similar constituent structures, and all these are of the crystalline solids. Now we will learn in the next lecture the classification of the crystalline solids. But if student you understand well what is these crystalline solids and amorphous solids, and which are the characteristics of crystalline solids and amorphous solids, and how we can distinguish them from each other. Again, if you learn about the isomorphism and polymorphism very well, then you subscribe, share and like this video, and also tell the other student to subscribe and like this video and to watch this video, because this is very important for your board examination and your all types of entrance examination. Thank you.